Hey everyone, welcome back to my channel Beaker and Board. In my previous videos I have discussed the techniques of writing the IUPAC nomenclature of alkanes, alkenes, alkynes and compounds having one functional group. I have also shared some short videos where you will get more examples. Now today's class is entirely about discussing the IUPAC nomenclature of compounds having more than one type of functional group. Now we know that there are different types of functional group, like we have the carboxylic acid functional group, we have aldehyde functional group, we have ketone functional group, the alcohol functional group, the nitrile or the cyano functional group, and so on. But all the functional groups do not get equal priority. All the functional groups are not equally important. Some functional groups have high priority order and some functional groups have less priority order. And there is a chart for that I will be providing you. Follow the class till the end so that you understand the rules and you also get to practice some questions from the previous year NEET and JEE papers. Now, whenever you start writing the IUPAC nomenclature of such compounds having multiple functional groups, the first step will be to identify the principal functional group. Now, what is the meaning of principal functional group? Principal functional group is that which gets more priority. The functional group that lies above in the chart is called the principal functional group, and the functional group that lies below is called the secondary functional group. That means principal functional groups are those that lies above in the chart which gets higher priority. Next step will be to identify the secondary functional group. That means the functional group that lies below in the priority list. The functional group lying above will be called the principal functional group, and the functional group that lies below will be called the secondary functional group. After that, the third rule is to select the parent chain. And how do you select the parent chain for such compounds? Remember, if the given organic compound has any such functional group which has carbon atom in it, like for example, if it has carboxylic acid functional group, or if it has aldehyde functional group, or if it has ester functional group, then these functional groups are itself having carbon atom or cyano functional group. So if such functional groups are given in the organic compound, remember to include those functional groups, remember to include those carbon atoms in the parent chain as well. That means if the compound has carboxylic acid group, this the carbon atom of the carboxylic group will be included in the parent chain. The carbon atom of the functional group will be included in the parent chain. And the next step is to include maximum number of double bond or triple bond. If the compound given to you has a double bond or triple bond in it, you have to include them in the parent chain as well. The fourth rule is, after the selection of the parent chain, the fourth rule will be numbering the parent chain. From which side should you number? The numbering of the parent chain has to be done in such a way that the principal functional group gets the lowest locant. Principal functional group gets the highest priority, so it will get the lower locant. The double bond or triple bond gets lesser priority, so it will get a higher locant. The secondary functional group or any alkyl group will be treated as the substituent. The secondary group or the alkyl group will be treated as the substituent and will be considered as and will be given the higher priority. After all the numbering and selections are done, the next thing is to assemble the whole thing according to the format that I have discussed already. And then you need to write the IUPAC nomenclature. So let's start with one example so that it is clear to you. Now, before getting into the example, see the priority order of the compounds, of the functional groups. Carboxylic acid gets the highest priority. So if any compound, if any organic compound is given to you where carboxylic acid along with any other group is given, remember that the carboxylic acid will be the principal functional group. As you go down the series, just a minute. So as you go down the series, the priority decreases. As you go down the series, the priority decreases. That means carboxylic acid functional group COOH will get the highest priority. After that, the sulfonic acid SO3H, the sulfonic acid group gets lesser priority. After that, the ester. So as you go down the group, as you go down the series, the priority decreases. And always remember, we always use the suffix of the principal functional group. The suffix of the principal functional group is used and the prefix of the secondary functional group is used. We'll be discussing some more examples, many more examples, so that you get the thing very clearly. Now that means so just now I have shown you a chart where I have discussed the priority order of the various functional groups. As you have seen that the carboxylic acid functional group occupies the highest priority. That means suppose if I take this compound, the compound which is on the screen, see we are having two functional groups. What is the first rule for that? Just now discussed. The first rule is to select the principal functional group, to identify the principal functional group. And how is it done? Depending on the chart, depending on the priority order. The carboxylic acid group COOH lies above, so this will be considered as the principal functional group, whereas the ketone functional group lies below. The functional group that lies below will be considered as the secondary functional group. And whenever you write the IUPAC name, remember, for the principal functional group we always use the word suffix. We use suffix for the principal functional group. That means for COOH the suffix is oic acid. The suffix for carboxylic acid group is oic acid, whereas the suffix for the ketone functional group is oxo. Here we are having the ketone functional group, C double bond O, ketone. On both the sides we are having alkyl group. On both the sides we are having alkyl group. So this is a ketone functional group. And for the secondary functional group we use prefix. And the prefix for ketone is oxo. So after the selection of the principal functional group and the secondary functional group, the second step is to select the secondary functional group. That means the identification is done. COOH is the principal functional group, whereas the ketone is the secondary functional group. After that, the third step is to find the parent chain. How to find the parent chain? As already said, if the functional group itself is having carbon atom, you have to include that within the parent chain. Now see, we are having two functional groups here. One is COOH and the other one is the ketone, C double bond O, and both of them are having the carbon atom. So we have to include the carbon atom of the carboxylic acid in the parent chain. So your parent chain will be somewhat like this. The parent chain will be somewhat like this. Include the carbon atom of the principal functional group. See, both the carbon atoms, ketone carbon and carboxylic carbon, COOH carbon and ketone carbon, C double bond O carbon, both are included within the parent chain. This comes under parent chain. After the parent chain, what was the last rule? After the parent chain selection, the last rule was to number. Numbering of the parent chain. How do you number the parent chain? As already said, that the principal functional group gets the highest priority and will get the least locant. The principal functional group should get the least locant. That means the carboxylic group will be the carbon number 1. Then this is 2, 3, this becomes 4. Just a minute. This is 5 and this is 6. That means we are having 6 carbon atoms in which the principal functional group COOH carbon atom gets the least locant, that is 1. So after the selection, after the rules are followed, what do we need to do? We need to assemble according to the format. What is the format? Whether we are having any side chain or not. No alkyl group is there. Simply the carbonyl group, the ketone functional group. As already said, the secondary functional group will be treated as the side chain. The secondary functional group will be treated as the substituent. The secondary functional group will be treated as the substituent. And this has to be written earlier. So that means according to the format, the side chain or the substituent in alphabetical order. We are having only one substituent, so 5-oxo. At the 5th position, we are having the ketone functional group. The ketone functional group being the secondary functional group will be, we have to use the prefix for that. So 5-oxo. Then after that we have the word root. Word root, there are 6 carbon atoms, so it is hex. Hex. All the carbon atoms are single bonded to each other. There are no double bonds or no triple bonds. So hex N. Hex N. And at the 1 position we are having carboxylic acid, COOH, which is the principal functional group. So we have to use the suffix for that, that is the oic acid. 5-oxohexane oic acid. But E and O, 2 vowels cannot be adjacent to each other. E and O are just adjacent to each other, which is not possible. So what do you need to do? You just need to cut out the E from the last part. You just need to cut out the E from the last part. So it becomes hexanoic acid. Hexanoic acid. Just a minute. (5-oxohexanoic acid). This is the IUPAC nomenclature of the given compound. Let's discuss some more examples so that you get to understand this very clearly. Let's suppose if we take this is the compound given to you. So obviously again we can see that there are 2 types of functional group. One is the OH functional group and the other one is the ketone functional group. This is the ketone functional group and this one is the alcohol functional group. Now, according to the priority list, ketone becomes the principal functional group, and we will use the suffix for that. And alcohol being lowered at the lower position becomes the secondary functional group, and we will use the prefix for that. The ketone functional group has the suffix -one. You will use the suffix -one for this. The suffix for ketone is -one, whereas the prefix is -oxo. And for alcohol, the prefix is hydroxy. That means the first two steps, identification of the principal functional group and the secondary functional group, is done. After that, we need to find out the parent chain. Since this is a cyclic compound and there are no side chains, no more alkyl group, so this is the parent chain. Now the numbering, the fourth step is the numbering. This is a cyclic compound, no other alkyl chain, no other carbon chain is there. So this is the parent chain only. So after that, numbering. How will you number? The principal functional group will get the highest priority, that means the least locant. So ketone will get locant 1. Now the numbering. After that, after the principal functional group, the double bond or the triple bond gets the more priority. That means double bond or triple bond will get the lower locant. That means after that, we are having the secondary functional group, or you can also say the alkyl group. The secondary functional group gets the less priority, so it will get the highest locant. So OH, the carbon atom containing OH, will get the locant 5. So after that, we need to assemble. All the steps are done. After the assembling, what does it become? The name then becomes, at the 5th position we are having no other alkyl group is there. As already said, the secondary functional group will be treated as the substituent. So just following the format, the substituent or the side chain is written first with the locant. So it is 5, not all, it is 5 hydroxy. Since alcohol group is the secondary functional group, we will use the prefix for that. So 5 hydroxy. After the side chain, we say cyclo. Since this is a cyclic compound, so we need to use the word cyclo. 5 hydroxy cyclo. How many carbon atoms are there in the ring? There are 6 carbon atoms. See, I have already marked them. There are 6 carbon atoms. So cyclohex. So 5 hydroxy come under the side chain part. Then, as already said, we need to use cyclo. After the cyclo, we use hex. Hex being the word root. Word root means the number of carbon atoms in the parent chain. In the given compound, there are no more carbon chain. So that means this becomes the parent chain itself. The ring is the parent chain. Cyclohex. Now there is a double bond. The double bond position is 3. So cyclohex 3. Cyclohex 3 in, and at the 1 position we are having one. But again, in E and on O are vowels together. So we will not use 2 vowels. What will we do? We'll simply remove the word E. Cyclohex 3 in 1 on. This is how you write the IUPAC name. So 1 on is the suffix of the principal functional group. Suffix of principal functional group. 3-ene determines the nature of carbon-carbon bond. Nature of carbon-carbon double bond with the locant. With locant. 3 is the locant. At carbon number 3, the double bond is placed. So it is 3-ene. I hope it is clear. Let's move to another example. Okay. Now let's discuss some more examples. See, when you write, this is just a precaution. When you write IUPAC name, the full IUPAC name is a one word. There is no space in between. But whenever you name esters or whenever you name acid, anhydride and halide, a space is given. Otherwise, the whole thing seems to be one word. There is no space in between. Let's practice a few more examples. You will understand through that. Suppose, let's start with this example. This example, see. Example number 1. See, here we are having, what are the functional groups? The first step is to find out the principal functional group and then the secondary functional group. According to the priority list, CHO, that means the aldehyde functional group, lies above and is called the principal functional group, and we use the suffix for that. We use the suffix for this compound, which is al. If you find out the chart, I have already explained that to you. In the chart it is given the suffix for aldehyde is al, whereas OH, which lies below, alcohol group which lies below, behaves as the secondary functional group. Secondary functional group, and we use the prefix for that. For secondary functional groups, we write the prefixes. And what is the prefix? The prefix for OH functional group is hydroxy. The prefix is hydroxy. After the identification is done, what do? We find out the parent chain. And if the principal functional group itself contains carbon atom, it should be included within the parent chain. So our parent chain is somewhat like this. The parent chain is somewhat like this, such that the OH and CH3 both are included as the substituent or the side chain. We have a double bond as well. Now after the selection of parent chain, we number. And how do we number? The principal functional group is given the lowest locant, that means this is carbon 1. Then this becomes carbon 2, this is carbon 3, this one behaves as carbon 4, and this one is carbon 5. So what does it become? That the parent chain has 5 carbon atoms, including the carbon atom of the aldehyde functional group. The parent chain has 5 carbon atoms, including the carbon atom of the aldehyde functional group. Now after the parent chain selection and numbering is done, we come to the naming. How do we do it? We have a methyl group and we have a hydroxy group. Hydroxy H comes first, so obviously it will be 4-hydroxy. 4-hydroxy, obviously side chain with the locant. So 4-hydroxy, 2-methyl. You don't follow the number sequence, you follow the alphabetical sequence. H alphabetically lies before, whereas methyl M comes after. So 4-hydroxy, 2-methyl, and then after that we write that there are 5 carbon atoms, so pent. And then we are having double bond at the 2 position, pent 2-ene 1-al, pent 2-ene 1-al. This is how you write. Now see, this whole thing is a one word. There is no space in between. But always remember that there is a dash between a number and an alphabet. You always need to give a dash between a number and the alphabet. You have been seeing from the past videos as well that, see here, between 4 and hydroxy H there is a dash. Between Y and 2 there is a dash. Between 2 and methyl M there is a dash. Between pent T and 2 there is a dash. Between each alphabet and a number there will be a dash. After this, let's come to the next example. The next example is somewhat like this. As you can see that this is an ester functional group. I have already taught you in the previous video how to name the ester group. How does it look like? It is somewhat like this: C double bond O, O, R dash. So this is the ester functional group. This becomes the ester functional group. Whereas this part, this becomes the R dash part. R dash. So obviously, and then we are having hydroxy OH. We have OH functional group. Now according to the priority list, the ester functional group behaves as the principal functional group. The ester is the principal functional group and we use the suffix OH for that. We use the suffix OH for that. And then we are having the OH. OH is the secondary functional group. OH is the secondary functional group and the prefix is used, which is hydroxy. Now, while naming the ester, what do we do? Ester the ester being principal functional group is supposed to be written at the end. But whenever we write ester, how do we start? Whenever any compound having ester functional group is given, you always name the R dash first. You always write the name of R dash first. And what is the R dash here? The R dash is a CH3 group, methyl group. So how do you write? It is simply methyl. Now, as already said, whenever you write the IUPAC for ester, there is a space. See, after methyl, I'll give a space. After the space, what will you write? Then start the numbering. It is 1, 2, 3, 4. That means there are 4 carbon atoms. You need to include the carbon of the ester functional group as well. This is the parent chain. This is the parent chain. You need to include the carbon atom of the ester functional group. So what does it become? Methyl. Then again, as following the format, side chain, it is 3 hydroxy, methyl, 3 hydroxy. Then we are having the no more double bond or triple bond. Word root is but because 4 carbon atoms are there, no space is to be given. 3 hydroxy but, and then it is N, butane, and for prefix is OH. That means butane OH. But again, E and O cannot be written together. So it is methyl 3 hydroxy butanoate. Don't include, it is like this, ANOATE, butanoate together. There is simply a space between the methyl and the other part. Methyl 3 hydroxy butanoate. There is a space between methyl and 3 hydroxy. See, I have given a space between methyl and then the other part. Methyl is the R dash group. R dash group attached to oxygen atom of ester. We have to label that first. Then 3 hydroxy becomes the side chain. 3-hydroxy becomes the side chain or the substituent. Then but becomes the word root. But becomes word root. Then an or ane becomes the nature of carbon-carbon bond, carbon-carbon single bond. And OAT is the suffix. OAT is the suffix that we use for esters. OAT is the suffix that we use for the ester. Whenever you have ester, you use the suffix OAT. Now after this, let's move to another example that is also an ester. See, number 3 is also an ester compound. It is not having any more groups, just a single functional group. This is a single functional group or simply the principal functional group. No more functional groups are there. This is a compound containing only one functional group. And what is that functional group? That is the ester. That is the ester. And I hope you can see very well, this becomes the R dash part. R dash, that means the alkyl group which is to be named first. How do you do it? How many carbons are there? See, there are 3 carbon atoms. In the R dash part, there are 3 carbon atoms, which means that this is the propyl group. Propyl, because it is having 3 carbon atoms. Propyl. After that, what do? We are having no more side chains or no more secondary functional groups are there. So it is propyl. Now what is this? This part. How to label it? This is carbon atom 1, 2, 3. At the 2 carbon there is a methyl group. So propyl, then don't give any dash, simply give a space. 2-methyl propyl, 2-methyl, then it is propanoate. Methyl propanoate. That means this propyl, the propyl that we have written at the beginning, is the R dash part. 2-methyl propanoate. Remember that the ester functional group itself contains carbon atom. The ester functional group contains carbon atom, so it is given as 1. And then at the 2 position there is a substituent, a side chain, which is methyl. So it is propyl 2-methyl propanoate. Now let's take another example, and this will be a little different from the previous examples and very common type of questions that are asked in your comparative exams. Let me show you the example first. Let me write the compound. This compound is somewhat like this. And very interestingly, the common name for this compound is citric acid. This is citric acid which is found in all lemons, in all citrus fruit, in lemons or unripe grapes. This acid is found. So now let's learn how to write the nomenclature for this kind of compound. Remember one thing, this is a very important rule, that if you are having, if an organic compound is given to you where more than two identical principal functional groups are there. See, here we are having 2 types of functional groups. We are having 2 functional groups here. And what are those functional groups? We are having the carboxylic acid functional group and we are also having one OH, alcohol functional group. But the problem is we are having 3 carboxylic acid group, whereas OH is only one. So remember one thing, if any such compound where more than two identical principal functional group, more than 2 identical principal functional group is there. See, carboxylic group lies above, so it is the principal functional group, whereas OH lies below and it becomes the secondary functional group. Secondary functional group. So if any organic compound is given to you where more than 2 identical principal functional group is present, then remember that they will be treated, the principal functional groups will be considered as substituents. They will no longer be part of the parent chain. They will not be considered in the word root. They will be only considered as substituent. They will not be considered as the parent chain. They will be only considered as substituent. This is a very important rule. Not within the parent chain. Not a part of the parent chain. So what do you do? Let's start the numbering. Don't include any of the 3. There are 3 carboxylic acid group. All of them will be a part of the substituent or the side chain. OH is already a side chain. It is secondary. Secondary functional groups are always considered as side chain or substituent. You have been seeing many examples from the beginning of the class. And we have considered the principal functional group to be a part of the parent chain. However, if there are more than 2 principal functional group, identical principal functional groups are there, then they will be treated as substituent, not a part of the parent chain. So if you number now, what does it become? It is somewhat like this is 1, 2, and this becomes 3. So this is the parent chain. The COOH, all the 3 COOH carboxylic group will be treated as the side chain or the substituent. Just like OH is already a side chain. It is a secondary functional group. But the COOH carboxylic groups will also be treated as side chain because there are 3 carboxylic groups. Identical groups are multiple. So how do you write the name now? It is just like the previous things. It is at the 2 position, OH is there. So it is 2-hydroxy. 2-hydroxy. Then we come to the parent chain. 2-hydroxy. Then it is 3 carbon atoms. So it is prop. Carbon-carbon single bond. So N. Now see at 1, 2 and 3 position you will not include the oic acid anymore. They will not. What do? We write the suffix for the principal functional group. But here we will not be writing like that. Since the carboxylic groups, in spite of being principal, are multiple in number, that is why they will be considered as a part of the side chain. So 2-hydroxy propane, then 1, 2, 3. You need to write the locant as well. Then tricarboxylic acid. Tricarboxylic acid. I can illustrate it in Bengali as well. যদি কার্বক্সিলিক গ্রুপ একটা থাকতো তাহলে আমরা কি ইউজ করতাম? ওইক অ্যাসিড বলতাম। যদি কম্পাউন্ডটা এরকম হতো, সাপোজ কম্পাউন্ডটা যদি এরকম হতো CH2 CH2 COOH অ্যান্ড OH, কম্পাউন্ডটা যদি এরকম কিছু একটা হতো তাহলে আমরা কি দেখতে পাচ্ছি যে CO2H প্রিন্সিপাল ফাংশনাল গ্রুপ, আর সেটার জন্য আমরা কি ইউজ করতাম, ওইক অ্যাসিড ইউজ করতাম, ওইক অ্যাসিড। আর OHটা আমাদের সেকেন্ডারি ফাংশনাল গ্রুপ, আর সেটার জন্য আমরা কি ইউজ করতাম, আমরা ইউজ করতাম হাইড্রক্সি। কিন্তু এখানে প্রবলেমটা হচ্ছে যে কম্পাউন্ডটা দেওয়া আছে সাইট্রিক অ্যাসিডটা, সেখানে দেখতে পাচ্ছি যে ওখানে একটা CO2H নেই, ওখানে তিনটে আছে। তো যখন দুটোর বেশি থাকবে তখন কি করব, তখন আর প্রিন্সিপাল ফাংশনাল গ্রুপের সাফিক্স ইউজ হবে না, প্রিন্সিপাল ফাংশনাল গ্রুপের সাফিক্স তখন ইউজ করব না, তখন সিম্পলি ট্রাই দিয়ে শেষ করব। তিনটে আছে তাই ট্রাই কার্বক্সিলিক অ্যাসিড। যদি একটা থাকতো তাহলে যেমন যদি এটারই লিখি তাহলে কি হবে, সেটা এটার 1 2 3, তাহলে এটার কি লিখবো, এটা হবে আমাদের 3 হাইড্রক্সি প্রোপানোইক অ্যাসিড। যেরকমভাবে সিম্পলি লেখা হয়, যেরকম আমরা সিম্পলি লিখি সেরকমভাবেই লিখব, কারণ এখানে CO2H একটাই আছে। কিন্তু যে সাইট্রিক অ্যাসিডের এক্সাম্পলটা দিয়েছি, CO2H এর কি ইউজ করি, ওইক অ্যাসিড ইউজ করি, ওইক অ্যাসিড দিয়েই শেষ করেছি। কিন্তু যেহেতু CO2H তিনটে আছে, সাইড চেন আলাদা আলাদা না, সেম প্রিন্সিপাল ফাংশনাল গ্রুপটা সেম আছে, তিনটে আছে, তাই জন্য আর ওইক অ্যাসিড হবে না। যদি তোমরা ট্রাই ওইক অ্যাসিড লেখো তাহলে সেটা ভুল হবে, যদি তোমরা ট্রাই কার্বক্সিলিক অ্যাসিড লেখো তাহলে সেটা ঠিক, ট্রাই কার্বক্সিলিক অ্যাসিড লিখলে সেটা ঠিক। কিন্তু তোমরা যদি এই ট্রাই কার্বক্সিলিক অ্যাসিড না লিখে যদি এরকম লেখো ট্রাই ওইক অ্যাসিড, তাহলে কিন্তু সেটা ভুল হবে। ওইক অ্যাসিড দিয়ে শেষ করতে পারবো তখন যখন একটাই CO2H থাকবে, এখানে তিনটে আছে, তাই জন্য আমরা ট্রাই কার্বক্সিলিক অ্যাসিড লিখব। আমি আরও এরকম এক্সাম্পল দেবো, তাহলে তোমরা আরও ভালো করে বুঝতে পারবে। So just like the previous example of citric acid, this is the same one. Here we are having 3 identical principal functional group. তো ওখানে যে রুলটা তোমরা ইউজ করেছো এখানে সেটা ইউজ করবে। ওখানে দেখেছিলে যে যদি তিনটে মোর দ্যান দুটোর বেশি যদি আইডেন্টিক্যাল প্রিন্সিপাল ফাংশনাল গ্রুপ হয় তাহলে সেটাকে আমরা আর প্যারেন্ট চেনে ইনক্লুড করি না। প্রিন্সিপাল ফাংশনাল গ্রুপ যদি দুটোর বেশি হয় তাহলে সেইটাকে আমরা আর মেন চেনে বা প্যারেন্ট চেনে ইনক্লুড করি না। এখানে 3টে অ্যালডিহাইড গ্রুপ আছে, আমরা একটাকেও কিন্তু মেন চেন বা প্যারেন্ট চেনে ইউজ করব না। তা নাম্বারিং কিভাবে করব, নাম্বারিং 1 2 3, তিনটেই অ্যালডিহাইড আমাদের সাইড চেন হয়ে কাজ করবে, তিনটে অ্যালডিহাইড আমাদের সাইড চেন হিসেবে কাজ করবে, কোনোভাবেই কিন্তু সেটাকে প্যারেন্ট চেনে রাখা যাবে না, বিকজ এখানে তিনটে আইডেন্টিক্যাল প্রিন্সিপাল ফাংশনাল গ্রুপ আছে। তাহলে এখানে আবার নাম্বারিংটা করলাম 1 2 3. So after that what will you do, you will start with the IUPAC. So it is 1 bromo as usual, যেভাবে সাইড চেনটা করতে হয় আগে সাইড চেন 1 ব্রোমো, তারপরে আসবে ওয়ার্ড রুট হচ্ছে তিনটে, প্রোপ 1 ব্রোমো প্রোপ, প্রোপেন, কার্বন কার্বন সিঙ্গেল বন্ড আছে সো প্রোপেন, and then after that তিনটে অ্যালডিহাইড আছে সো ইট ইজ 1 2 3, 1 2 আর 3 পজিশনে আছে সো 1 2 3, ট্রাই তিনটে আছে তাই ট্রাই, একটা ড্যাশ থাকতে হবে ভেতরে মধ্যখানে, 1 2 3 ট্রাই। ওখানে যেরকম দেখেছিলে কার্বক্সিলিক অ্যাসিড, এখানে কি হবে কার্বাঅ্যালডিহাইড, 1 2 3 কার্বাঅ্যালডিহাইড, বা এটাকে তোমরা এভাবেও বলতে পারো কার্বন প্লাস অ্যালডিহাইড, কার্বন প্লাস অ্যালডিহাইড থেকে হয়ে যাচ্ছে কার্বালডিহাইড। সো 1 ব্রোমো প্রোপেন 1 2 3 ট্রাইকার্বালডিহাইড। তো সবসময় মনে রাখবে যদি আইডেন্টিক্যাল গ্রুপ থাকে, দুটোর বেশি যদি আইডেন্টিক্যাল গ্রুপ থাকে, তাহলে সেইটাকে আমরা আর প্যারেন্ট চেনে ইউজ করি না, সেইটা আমাদের সাইড চেনের কাজ হয়। আর যে শুধুমাত্র সাইড চেন হিসেবে কাজ করবে সেটাও না, তার সাফিক্সটাও আমরা আর ইউজ করব না। আমরা অ্যালডিহাইড গ্রুপ থাকলে কি ইউজ করব? CHO যখন আমাদের প্রিন্সিপাল ফাংশনাল গ্রুপ হয় তখন আমাদের সাফিক্সটা হয় অ্যাল, সাফিক্সটা অ্যাল হয়, অ্যাল দিয়ে শেষ করার কথা। We are supposed to end the IUPAC with al, কিন্তু এখানে আমরা দেখছি যে অ্যালডিহাইড গ্রুপ 3টে আছে। তো যখনই এরকম সিচুয়েশন অ্যারাইজ করবে যে দুটোর বেশি প্রিন্সিপাল ফাংশনাল গ্রুপ হচ্ছে, তাহলে সেইটাকে আর আমরা প্যারেন্ট চেনে ইনক্লুড করব না, ওটা প্যারেন্ট চেনের বাইরে থাকবে, সাইড চেন হিসেবে থাকবে। আর তাছাড়া যখন শেষ করব তখন আর অ্যাল দিয়ে শেষ করব বা উইক অ্যাসিড দিয়ে শেষ করব না, তখন কার্বক্সিলিক অ্যাসিড বা কার্বালডিহাইড হিসেবে লিখব। নেক্সট এক্সাম্পলটা দেখো, তাহলে আরো ক্লিয়ার হবে। নেপার আমাদের 3টে আইডেন্টিক্যাল গ্রুপ আছে। প্রায়োরিটি অর্ডারটা যদি দেখো তাহলে সাইনাইড উপরে থাকে আর কিটোন ফাংশনাল গ্রুপটা নিচে থাকে। তাহলে সায়ানোর কি ইউজ করা উচিত? সায়ানোটা আমাদের হবে প্রিন্সিপাল ফাংশনাল গ্রুপ, যেটার আমরা ইউজ করব সাফিক্স, ইউজ করা উচিত সাফিক্সটা। আর কিটোন ফাংশনাল গ্রুপটা হবে আমাদের সেকেন্ডারি ফাংশনাল গ্রুপ, যেটা কিন্তু হওয়া উচিত আমাদের প্রিফিক্স। তো কিটোনের জন্য প্রিফিক্স ইউজ করি আমরা অক্সো, আর সাফিক্স আমরা ইউজ করব নাইট্রাইল। কিন্তু এইখানে একই কেস আগেরটার মতনই, আগের দুটোর মতনই, এখানে আমাদের প্রিন্সিপাল ফাংশনাল গ্রুপ 3টে আছে। তাহলে আমরা কিন্তু ওই 3টেকে আর প্যারেন্ট চেনে ইনক্লুড করতে পারবো না, ওটা আমাদের সাইড চেন হিসেবে কাজ করবে। ঠিক যেরকম আমাদের কিটোন ফাংশনাল গ্রুপটা সাইড চেন, ঠিক সেরকম ভাবে এই 3টে সায়ানো গ্রুপ, 3টে CN ফাংশনাল গ্রুপ আমাদের সাইড চেন হিসেবেই কাজ করবে। এবার তাহলে আমাদের প্যারেন্ট চেনটা কি হবে? প্যারেন্ট চেন আমাদের হবে এইটা, এইটা আমাদের প্যারেন্ট চেন, যার মধ্যে 4টে কার্বন অ্যাটম আছে। এবার নাম্বারিং কিভাবে করব? নাম্বারিং আবার মাথায় রাখতে হবে যে প্রিন্সিপাল ফাংশনাল গ্রুপটা যেন লোয়ার লোক্যান্ট পায়। তাহলে প্রিন্সিপাল ফাংশনাল গ্রুপ যদি লোয়ার লোক্যান্ট পায়, তাহলে কি হচ্ছে আমাদের নাম্বারিংটা যদি আমরা লেফট হ্যান্ড সাইড থেকে করি, তাহলে দেখো কি হচ্ছে 1 2 3 4। তাহলে লেফট হ্যান্ড সাইড থেকে করলে প্রিন্সিপাল ফাংশনাল গ্রুপ গুলো কি লোক্যান্ট পাচ্ছে? 1 পাচ্ছে, 2 পাচ্ছে আর 4 পাচ্ছে। আর যদি রাইট হ্যান্ড সাইড থেকে করো, যদি রাইট হ্যান্ড সাইড থেকে করো তাহলে প্রিন্সিপাল ফাংশনাল গ্রুপ কি কি লোক্যান্ট পাচ্ছে? পাচ্ছে 1 পাচ্ছে, 2 পাচ্ছে, 1 3 আর 4 পাচ্ছে। প্রিন্সিপাল ফাংশনাল গ্রুপ গুলো 1 3 আর 4 পাচ্ছে। তাহলে অবভিয়াসলি আমাদের লেফট হ্যান্ড সাইড নাম্বারিংটা ঠিক। প্রিন্সিপাল ফাংশনাল গ্রুপ গেটস মোর ইম্পর্টেন্স দ্যান দ্য সেকেন্ডারি ফাংশনাল গ্রুপ। তাহলে আমাদেরকে এমন ভাবে নাম্বারিং করতে হবে যাতে প্রিন্সিপাল ফাংশনাল গ্রুপ গুলো লোয়ার লোক্যান্ট পায়, লোয়ার লোক্যান্ট পায়। তাহলে আমরা যদি লেফট হ্যান্ড সাইড থেকে নাম্বারিং করি তাহলে আমাদের লোক্যান্ট আসছে 1 2 আর 4, আর রাইট হ্যান্ড সাইড থেকে করলে আসছে 1 3 আর 4। তাহলে রাইট হ্যান্ড সাইড নাম্বারিংটা ভুল আর লেফট হ্যান্ড সাইড নাম্বারিংটা ঠিক। তাহলে আমাদের এক্সাক্ট নাম্বারিংটা আরেকবার যদি লিখে নিই তাহলে আসছে আমাদের এরকম কিছু একটা। লেফট হ্যান্ড সাইড থেকে করলে আসছে 1 2 3 4। তার মানে 1 2 আর 4 নাম্বারিংটা কারেক্ট। তাহলে আমাদের IUPAC টা হবে, IUPAC হবে আমাদের অবভিয়াসলি আগে সাইড চেন, 3 অক্সো মানে সেকেন্ডারি ফাংশনাল গ্রুপ 3 অক্সো। তারপরে আমাদের 4টে কার্বন আছে, 4টে কার্বন হচ্ছে আমাদের বিউট, কার্বন কার্বন সিঙ্গেল বন্ড তাই N, বিউটেন। এবার তারপরে হচ্ছে আমাদের 1, 2, 4, 1, 2, 4 ট্রাই কার্বোনাইট্রাইল। কার্বন কথাটা অ্যাড করতেই হবে, যেমন আগেরটা দেখেছো কার্বক্সিলিক অ্যাসিড, কার্বালডিহাইড, ঠিক সেরকম ভাবে এটা হবে আমাদের ট্রাই কার্বোনাইট্রাইল। নাইট্রাইল কথাটা আমরা কখন ইউজ করি? যখনই আমাদের সাইনাইড ফাংশনাল গ্রুপ থাকে তখন আমরা বলি নাইট্রাইল, তাহলে কার্বোনাইট্রাইল। This is the way you write the IUPAC nomenclature of compounds having more than two principal functional group. আমি আরো কিছু ক্লাস নেব যেখানে তোমাদের আরো বেশি IUPAC করাবো, সাথে সাইক্লিক ফাংশনাল গ্রুপ, সাইক্লিক গ্রুপ থাকলে আর অ্যারোমেটিক গ্রুপ থাকলে কিরকম ভাবে করতে হয় সেটাও শেখাবো। If you like this video, please like, share and subscribe to my channel so that I can provide you more videos which will be useful for you, not only for your boards or your school exams but also for your competitive exams. Thank you everyone.